Okay. Now, the next thing we're going to look at is what's probably going to come next, I think, is the graphing curves. So we need to be able to graph polynomials like this curve here. Now, it looks as if it might be fairly difficult to graph, but if we look at down here, and all I've got is a few points. I know that up here is what's called a maximum turning point. It crosses here, here, and there's a minimum turning point. Then pretty much there is only one graph that can go through there. And that's that one, which is the one we started with. So the whole idea of how you use derivatives to graph functions is we're looking for these. This is a maximum turning point or a local maximum turning point. This is a local minimum turning point or a minimum turning point. What do we know about this point? The tangent or the gradient of the tangent is 0 here. The gradient of the tangent is 0 here. So we're going to use that to graph these points or to graph this curve. So let's start with this curve. We want to graph y equals 2x cubed minus 3x squared. So the first thing we're going to do is we're going to find the first derivative, dy dx. And there was a reason why I said we're going to find the first derivative, because that's exactly what we're going to do. We're going to find the first. So 3 times 2 is 6x, 1 less than 3 is 2, minus 2 times 3 is 6x, and 1 less than 2 is 1. So that's the first derivative. Now, what do we want with the first derivative? We want to find out when that equals 0, because that's when the tangent's going to be 0. Back here, what do we know about this point here? The tangent or the gradient of tangent is 0. This point, the gradient of the tangent is 0. So we are going to let this equal 0. And let's put turning points occur at dy dx equals 0. I always like to write that. So 6x squared minus 6x equals 0. And we can factorize this. We can take a common factor of 6x out, and we're left with x minus 1 in the brackets. So when is this equal to 0? Well, if x equals 0, that's going to be 0. And if x equals 1, I also know that 1 minus 1 is 0, so anything that this is times 0 is going to give us 0. So I know up here that there's going to be a turning point at x equals 1, and there's going to be a turning point at x equals 0. What might I want to find out next? I might want to find out the y value. Okay, so at x equals 0, what does y equal? This is the one that says y equals. So at x equals 0, y is going to equal 2 times 0 cubed minus 3 times 0 squared, which is just going to be 0. So something happens at 0, 0. At x equals 1, what does y equal? Y equals 2 times 1 cubed minus 3 times 1 squared. So 2 times 1 cubed is just 2 minus 3 times 1 squared, which is 3. So 2 minus 1 is minus 1. So x equals 0, 0, something weird happens. And at x equals 1 minus 1. Okay. Now, the other thing that would be really, really nice is we could probably guess that this is going to be a maximum here, and this is going to be a minimum. But it'd be nice if we didn't just guess, if we actually knew. So if we're going to look at the second derivative, d2y dx squared, the second derivative, here's the first derivative, 6x squared minus 6x. So this is going to be 12x minus 6. Sorry, minus 6. So we bring the 2 times 6 is 12x minus 6. Now, at x equals 0, again, we're looking at these 2 points at x equals 0 and x equals 1. At x equals 0, d2y dx squared equals minus 6. If we put this in here, we get 12 times 0 is 0, minus 6 is minus 6. Now, I know, and it's going to come to this, that if this is a negative, we know that that is a maximum turning point. So we know that that's a maximum turning point. And again, what we're going to do is look at d2y dx squared at x equals 1. At x equals 1, what does d2y dx squared equal? It's going to equal, we put this in here now, so 12 times 1 is 12, minus 6 is 6. And because this is positive, we know this is a minimum. So a negative means it's a max. Negative implies it's a max, and a positive implies that it's a minimum. So I know that's a minimum, and then it's just a matter of drawing a line through all of this. And that's a nice simple graph of y equals 2x cubed minus 3x squared. And that's probably where we're going next. Thanks.